Hi everyone. Today's lesson is on displacement time graph, which is a topic in mechanics. Mechanics is a part of physics. It is included in high school physics curriculum in most countries, including Canada. It deals with the effects of forces on bodies at rest or in motion, conservation of momentum, conservation of energy, etc. In these lesson series, I am doing worked examples. Let's start with displacement time graph. Consider a particle starting from rest and moving in a straight line from a point O on a horizontal plane. Let's plot its displacement from O with time. Draw vertical and horizontal axes. These axes are for displacement and time respectively. Mark 0 to 12 seconds on the time axis with 2 seconds intervals. Mark displacements from 0 to 5 meters. Now plot the curve. Draw lines parallel to the displacement axis to find the displacement at each time. Draw red lines perpendicular to these lines. That is to measure the change in displacement at each time as shown. Then change in displacements are h1, h2, h3, h4, h5, and h6. In this curve, we see that h1 greater than h2 greater than, h3 greater than, h4 greater than, h5 greater than, h6. Also we can see that change in displacements in equal intervals varies. That means the velocity of the particle is not constant. Next we want to find what gives the velocity at a particular time on the displacement time curve. The following table gives the displacement at times 0 to 5 seconds. First, plot these on a graph. We get a graph as shown. Suppose we want to find the velocity at a certain time, let's say 3 seconds. Draw the tangent at the point. The blue-colored line is the tangent at that point. The velocity at that point is the rate of change in displacement with respect to time at that point. This is given by the gradient of the tangent. In this, the gradient of the tangent can be found by the right-angled triangle. The vertical height of the triangle is equal to 3.3 meters. Horizontal side is equal to 4 seconds. The gradient equals 0.825 meters per second, which is the velocity at time 3 seconds. We see that if we draw the tangents at other points, the gradients have different values. For these gradients to be equal, the curve should be a straight line. So the displacement time graph for a particle with uniform velocity is a straight line. Next we are going to work an example on uniform velocity. Now read the question carefully, taking care of the units. A car moves with a constant velocity of 60 kilometers per hour for 40 minutes and due to a road resistance moves with a constant velocity of 5 kilometers per hour for 10 minutes. In both intervals, the graphs are straight lines. Now let's plot the graph. Since the velocity is given in kilometers per hour, the time should be in hours. Let's draw the two axes. Vertical axis is for displacement, and horizontal axis is for the time. First draw the first part of the graph. Let BC be H1 and DC be H2. First, we have to find the gradient of the line of B. Gradient equals h1 by 3 over 2. The gradient gives the velocity of the car in the first part. That is 60 kilometers per hour. h1 over 2 by 3 equals 60. So h1 equals 40 kilometers. Next find the Gradient of line CD. It is equal to h2 by 1 over 6. Now h2 equals 5 by 6 kilometers. Total displacement of the car is 40 plus 5 by 6 kilometers. This is equal to 245 by 6 kilometers. Now we have to find the average velocity of the car. It is equal to total displacement by total time, which is equal to 49 kilometers per hour.